but before Mr. Dr. Chekarshov. Exactly.
Exactly. Yeah, thank you very much, Mr. Chairman. And it's a great pleasure to make a presentation after my European colleagues and my friends. And it's my presentation will be devoted to our experience to work in Atlantic mostly. And it will be not only about massive sulfides, but mostly about massive sulfides. But I will try to make a short overview about another type of mineral deposits, I mean nodules and crust in Atlantic. Well, yeah, this is outline. You see that Eve already showed you the global distribution of sea floor massive sulfides in the ocean, and you see here there is two main provinces of or geological situation for the sea floor massive sulfides. This is mid-ocean ridges in all oceans, and this is so-called back arc basins. And these two systems differ only tectonically and volcanically. But for both situations, it is a two necessary condition for the formation of hydrothermal mineralization. These conditions are magmatic chamber, the source of the heat, and the tectonics. So this combination of these two parameters makes possible to start this, to drive the circulation of the seawater inside, and as a result to form such a beautiful and huge amount of massive sulfide ores which we are dealing with. So the Russia historically started to work also in Pacific as well as it was started in East Pacific Rise in the beginning of 80s and in the end of 80s, and started to work in the Kuril Islands. But then we moved to Atlantic. It was 20 years ago approximately. And 20 years ago we started to work here, and beginning from this, every year we have an expedition, and as a results of these studies I will try to show you. Well, okay. So I will concentrate here on this part of this segment of mid-Atlantic ridge. Okay, now better. What's new discoveries? I will concentrate only on the recent last discoveries and at the mid-Atlantic ridge. So you see that during last 5 years there were discovered at least 5 new large seafloor massive sulfides. And the first one, this is chronologically, was discovered at 13 degrees and named Ashadze, after our main geologist. The second one was discovered 1 year later and named after another geologist, Russian Krasnov. The third one was discovered last year, and the last one was discovered this year and was named after the Russian football team, the Nice. Yes, because it was the day when the Nice won the Bavarian team and got a European Cup. And all the people on board, they made decisions that it should be in the record on the map. Such a great event in Russian football history. Yeah. Yeah. Well, now you see here these four huge deposits, and I will later make detailed information for all of them. But before it, I would like to show you the table with the classification of the massive sulfide deposits on Mid-Atlantic Ridge. And you see here that this line is important for us. You see there are two types of hydrothermal deposits in Atlantic. The first type is connected or related to basalts. So the hosted rocks are basalts. And another type is, this is a new type of deposits which was discovered in Logachev field in 1984. It was ultra-basic hosted. And for this moment, particularly this type of deposits is most interesting from geological and economical point of view, because the grades of the metals here are, they are comparable with deposits which we have in Papua New Guinea, which Nautilus are planning to start to product to exploitation in 2010 already. So this type of deposits are very important, and I'm sure that such type of deposits we will find in the southern part of Mid-Atlantic Ridge, and Brazilian geologists will get very important new discoveries. Well, now about geological setting and morphology of deposits which we have discovered last years. The first one is Ashadze. It was discovered, as I told already, 2003, and then extended later, and the last expedition was together with our French colleagues on board of a research vessel with a very French name, Pourquoi Pas. Yes, and it was very effective and give us a very interesting results. What are the features of this hydrothermal field? First of all, the Ashadze is the deepest for this moment. This is more than 4,000 meter depth, water depth. And there is a specific animal community around these active mounds. Then second feature is that it is related to ultramafic rocks, as I told you before. This is peridotites and gabbro. It consists of at least 4 sites. So this is a cluster of deposits. It's not one chimney or one mound. This is a cluster. And part of these sites are active and part are inactive. And I stress these inactive sites because from future, when we will talk about the production, we will start, of course, from inactive sites, because from environmental point of view, it's more logical and more comfortable for these animals who are living around these deposits. Well, so what is Ashadze is? This is the map, and you see that it is situated not on the Rift Valley. This is Rift Valley, and this is a slope, but on the slope, and this is approximately 8 kilometers between each of these side, and everywhere we have a different type of morphology of deposits. For example, if you will go, first of all, about tectonic control. We mapped based on bathymetry, and we made a morphological map, and we recognized some tectonic dislocations. And we see that there is a structural control of the location of all of the sites which we discovered. And here you see the cross-section across the Rift Valley, and here we have Ashadze 1, Ashadze 2, and Ashadze 4. And this is the numbers of the age of deposits. I will go for this information later. Well, now Ashadze 1. So this is high-resolution map. Approximately, this is 25 meters you see here. And this is how the field looks at the topography. So this is very rough topography, and here we discovered at least 4 or 5 active sites which are controlled by fault. It's evidently, yes. Such a photo we got from ROV, and you see here some of the chimneys already oxidized, and they are yellow by color, and the black one are the very fresh sulfides. And there are some animals here, actinia and others. And the actinia is the most popular and typical for this site animal. And some other slides and active smoker. We will show later the video, and you will see it in the movement. Yeah. As for the Ashadze 2, this is very interesting site, and Eve already showed you this map, and you see here that it is also very strict tectonic control. All of these mounts are hydrothermal, so they are sulfides, massive sulfides, and they are located along this line, which is tectonically by origin. And another structure which is extremely interesting, this crater, which is approximately 15 meters in diameter, but it is totally consists of massive sulfides. And the origin of this structure is still enigmatic. So we are still thinking how it could be formed. Was it explosion or was it dissolution? It is the subject for discussion. Well, the next one, very big one, named Semyonov. It was discovered last year. It has a very unusual geological setting because it connected with the seamount, which is oriented orthogonally to the Mid-Atlantic ridge. It is also connected with partly with ultramafic and partly with basalts. It's inactive, very important. It is very large, very large. You see here, we estimated the resources, of course this is potential resources, as 13.7 million ton. And also consists of 4 sites, is a cluster of deposits. And I should stress that we detected extremely high gold concentration in these sulfides, which is rather important. And this is a slide with the geological position of this Semyonov deposits. It is here on the slope, not in the Rift Valley. This is very typical for ultramafic hosted deposits. They are located not in the Rift Valley, but on the on the rift slopes. Yes, and this is a scheme. And I will show you this results, or some results of chemical analysis of the sulfides from northwest side. And look here, the average concentration of gold is 61.8 ppm, gram per ton. We checked it twice. And you see here, we found such a concentration of this noble metal. And for sure, we tried to make detailed mineralogical studies, and we found the native gold particles.
Please put the microphone.
Okay, sorry. And the next site is Logachev. It's very popular now, and it was visited many times by many international expedition, but it was discovered in '94 from Professor Logachev research vessel. It is also consists of 4 or maybe 5 separate sites. 2 of them are active, and another maybe inactive. And it has a very complicated composition. And secondary copper sulfides, especially enriched by gold again. So this is a geological position of Logachev. You see again that it is not in the Rift Valley, but on the top of the rift slope, rift mountain already. And here different geological maps for this, and this is a cross section. You see here that there is a control of deep fault zone, and it is situated on the it is located on the steppe, and there is a strict tectonic control again for Logachev 1 and for Logachev 2. And this is a map which was produced by ROV Victor. And here you will find the real mounts, sulfide mounts. All of them, they are 11. They are detected as a massive sulfide deposits itself. And you see here again that there is a very strict tectonic control. All of them, they are located along the line, which are tectonically controlled. Yes. So some images of these beautiful black smokers. They named after some ladies from the expedition: Anna Louise, Irina. So the French and Russian girls. Yes. So sometimes the chimneys are active, and you see here a lot of animals around. Sometimes they are inactive. For example, Quest mount, it's inactive and no life around. And Logachev 2 is very interesting because of very high grade of gold again, and some dead clams, and with the sulfides and new portions of lava. And again, at Logachev was discovered the same structure as a smoking crater. So, Krasnov deposits. This is very interesting from the point of view of their position, first, and their size or dimensions, second. It is situated on the conjunction between the volcanic high, neovolcanic high in the Rift Valley and Rift Mountains. And we mapped there two very big mounts or ore bodies, and the size of them is approximately 500 meters here. So if I already showed you the maps which were produced during Serpentine expedition, and this is once again, this is the ore body itself, and you see here the outcrop of massive sulfides which we detected by profiling. It was 100 meter high. So this is a huge ore body or massive sulfides. And such image we got from ROV. You see here, this is a real massive sulfide, sometimes with a secondary copper minerals. It is on the stage of alteration. It showed such alteration processes. And two last discovered sites which we visited this year. This is first one is Puy de Fôle. This is French one because it was discovered earlier in. First is Zenith. Okay, I will start from Zenith. It was discovered this May, as I told you. It is still very bad studied, but we know only that it is very large, very large. Here we have made a profiling, and we detected the massive sulfides along the 1 kilometer at least, one in one direction and half a kilometer at least in another direction. And the preliminary estimation is 11 million tons. And the first analytical data show us that this is mostly copper iron sulfides. It is inactive. We didn't detect any hydrothermal indication in the sea, near bottom waters. It is the geological map of this ore body. And the last one, this is Puy de Fôle. It was discovered in '96 by French colleagues, but it was visited after 12 years by our ship, and we found there a very interesting structures, they connected with the seamount. And it was very easy to study it because the surface of seamount is flat. This is like Guyot, where we study our crusts. And here we found this new field, and it consists of at least 7 hydrothermal deposits. So our French colleagues detected 1, and now we have already 6 of them, and this is very good object for the future investigation. So now about the composition. Here you see the concentration of the main metals, copper, zinc, gold, silver, cobalt, and nickel. And this is indication of the hosted rocks again. Ultra basic, basic, and questionable. And you see that the most interesting from the economical point of view is ultra basic hosted deposits. They have a very high concentration of copper, high concentration of zinc, high concentration of gold. And unfortunately, the big Krasnov field consisted mostly of iron sulfides, pyrite, marcasite, and but there is another small mount just near Krasnov, which has a copper zinc specialization. This is about the concentration. The same we see on the table, which show us the distribution of types of sulfide mineralization. The copper zinc, and copper iron types of mineralization related to